Okay, let's start the next session. So the next session is Unleashing Peak Performance, Mastering Flutter DevTools for Raising Fast Apps. So please welcome Ashita.
So hi everyone, I am Ashita, and today we'll be talking about how you can improve the performance of your apps. But before we begin into the session, I would like to share my Flutter story. So I began writing Flutter code in around 2018, and while doing Flutter, I realized that there is not a good and systemic way to find packages for your requirements. So if you see, Flutter has this awesome Dart and Flutter package ecosystem, which is more than 50,000 packages. But as users of those packages, it is very difficult for us to find the right package that will fit into our requirement, which is why I went ahead and built Flutter Gems. And today Flutter Gems is being used by more than 2 million Flutter developers, and it is helping Flutter developers find the right package for their need. I also run a FOSS developers group on Discord. So it is more than 4,000 members, and here we discuss about open source, anything in open source, be it Dart, Flutter or any other open source technology. And you can join the group either using the bit.ly link that is given above or simply by scanning the QR code. And in this group now currently we have a lot of Gen AI enthusiasts and experts, and I have seen people using the group lately for finding teammates for their hackathons. And I am also the founder of API Dash. So API Dash is an open source API client that works on both mobile and desktop, and it is currently the only cross-platform API client, and this has been completely built on Flutter. So the reason I built it was to show the power of Flutter as to how Flutter can truly enable us to build cross-platform apps, and we use Riverpod for state management here. So thanks Remy. And it is also a Google Summer of Code mentor org. So if any of you are students or beginners in software development and want to participate in Google Summer of Code in a Flutter org, do check it out. So nowadays mobile apps are everywhere. We use them for everything. In fact, this entire PPT I edited on a mobile, and I did not need a laptop anywhere on the go. And earlier adoption for mobile apps used to take a lot of time, but with the rise of ChatGPT and Claude, you've seen the day they dropped their apps, they were quickly able to rake in millions of downloads in like a very few days. And this means that our apps have to be production ready from day one. From day one, they need to be flawless. Now what happens when your app starts crashing, starts having a lot of performance issues, memory leaks, etc.? We have a frustrated user, and that user frustration leads to poor reviews, it leads to bad publicity of the product. And in today's days and age, it is very difficult to retain user trust and at the same time keep it growing. And for that, from a business perspective as well, it is very important that our apps are flawless, they are highly performant, and they fit in all the user expectations that user has. Like there shouldn't be any user janking or anything. And yeah, so these are some of the Flutter apps in the wild. It's been around 6.5 years, 7 years since Flutter came out. So we have apps like Dream11, which is more than 100 million users, daily active users, which has been built completely on Flutter. You have Google Pay on Flutter. You have an EdTech app called EdPunk on Flutter. And this is Zerodha, which is an investment management platform in India. And that's also been completely built using Flutter. So you can just understand the scale at which Flutter apps operate. So Yeah, so now we come to the key question. We are talking about a lot of successful apps, but what is it that makes an app successful? How do we define a successful app? And what are the constituents that we need to have an app as a successful app? So first is great user experience, and that is a completely non-negotiable thing. Your app needs to provide a great user experience. It needs to work seamlessly regardless of the device you use. Whether you have an MI phone, a Samsung phone or an iPhone, it has to work seamlessly. It should not slow down or crash while you are using it. And it has to be highly performant. And what are the things that we as developers should ensure? So firstly, we should ensure that there shouldn't be any janking anywhere. It should work flawlessly. We shouldn't have any frames that are being dropped, and we shouldn't have any slow animations. These are the things that make handling. So we need to have proper handling in the front end as well for all those failed API calls. Now, in terms of CPU, we need to ensure optimal CPU usage. We need to ensure that there is no UI thread blocking, and we'll look into it in more detail in the upcoming slides. Again, there shouldn't be any runtime errors or any sort of unexpected behavior in the app. We should make sure that all edge cases are covered. There shouldn't be any memory leaks, because those will lead to heat up of the phone, faster battery usage, and again, that's not something we want. And our app should always be small. We shouldn't have any unnecessary dependencies. And to achieve all this, basically, Dart gives us a suite of application performance monitoring tools called Dart DevTools, which can help us achieve all these things that we want to do. So these are some of the DevTools that are in Dart. So we have Flutter Inspector, we have Debugger, Logging View, Performance View, CPU Profiler, Memory View, Network View, and App Size Tool. So all of them are available for Flutter Mobile and Desktop, and for Flutter Web we only have Flutter Inspector, Debugger, and Logging View. And all the other tools, if you want to use it for Flutter Web, you can actually check out Chrome DevTools, and they give us similar functionalities. So now let's get into how you can launch DevTools in VS Code. So basically, to do that, you have to select the target platform. So you can see here it's macOS Darwin, and select a device that you want to use. Then you have to simply run. Basically, your app should be running, and then you can either launch DevTools from the status bar, or you can also use the command palette. Yes, so you can also use the command palette here. So using this command palette, you can either open DevTools in a web browser completely separate, or you can open them individually in VS Code as well. So if you click on, say, open CPU profiler page, it will open up in VS Code itself. So like this is how it looks like when you open Flutter Inspector on VS Code. And let us see how it looks in web browser. So this is how it looks in web browser. You can see we have all the DevTools on the top. We have Flutter Inspector, Performance. So basically, Flutter Inspector helps you with any layout issues that are there. So if you want to look into any layout issues, you choose Flutter Inspector. Performance issue will help you with any janking, and we'll be looking into performance DevTools in detail. CPU Profiler also will cover in detail. Memory is again for any unexpected memory leaks that might occur in your app. So if you want to look into them, Memory view gives you a detailed view. We have debugger. We have the network view also for covering any network calls or API calls that we are making. We have logging, again to see any error logs that are getting generated. We have the app size tool, which helps in looking into the reasons why our app is a certain size. So many a times you might have assets that are unused, or you might have packages that are taking up a lot of memory and you want to reduce that. So in that case, again, app size is really helpful. And you have a deep links tool that has come up new. So this is how, yeah. So these are basically how the tools look like. Performance tool, the CPU profiler tool view. The memory view tool, yeah, the network, logging, and app size. So we'll now go into performance view, and I will be covering performance view and CPU profiler and network in the session today. But if you want to look into other DevTools as well, I have written a series of guided tutorials for all these DevTools, and you can find them on Medium in Flutter Gems channel. So performance view, again there's a study that has been done that says that more than 80% of people who download your app simply uninstall it because of performance issues. And that is a very big concern for businesses, because they spend billions of dollars to get you to download the app. And users typically love fast performing UI, and they hate janking. And these jankings come up in various methodologies. It will show up as slow loading times, it will show up as stuttering animations, and they make the user feel that the app is not responding. So we'll be doing a small exercise today, and you can find the source code for it at Ashita Prasad Performance View Demo on my GitHub. We'll be running a scenario to see how performance view works. Again, for launching performance view, we need to select the device, and you should always be running performance view on an actual device. The reason being, simulators and emulators have different hardware configurations, and because of that, the performance characteristics can be different. So always run it on an actual device. And a classic example is, say you are running a loaded MacBook Pro, and if you run it on your laptop versus say a low grade MI phone, and your user is using a low grade MI phone. So when you run it on your laptop, you won't get any issues. But when the user runs it on their phone, because their hardware is low grade and they have less RAM and things like that, it's going to show up as a lot of janking. So it's always recommended that performance view and all the CPU profiler view, you must always run it on real devices. Then whenever we run our code, there are three modes in which we run our code, either the run, debug, or profile. It's very important that you run it in profile mode here, because debug mode has extra assertions and checks which can actually slow down our app when we run it. Secondly, the way the code executes. In debug, it's just-in-time approach, whereas profile mode is a lot closer to the release mode, because it also uses AOT or ahead of time approach. So it's always recommended that you do it in profile mode. And here it's almost identical to the release mode, and there are very few additional checks that are there just to help the developer debug. Again, we'll be opening Dart DevTools to go to performance view, and this is how we'll do it. We'll click on profile. So when you click on profile, you can see here the code is executing and it's opening up in profile mode. So the performance view tool opened up. but we'll be opening it in a web browser. So you can see the performance tool here. So this is the top toolbar. What it does is that it helps you pause, play and stop any recording. You can also add a performance overlay. You can also enhance your tracing, and you can also set the profile granularity here. It can either be medium, low or high depending on your requirement. This chart is So this chart is basically the Flutter frames chart, and here you can see the frames. So all these frames that are marked in red are actually the slow frames, or the frames that will show up as janking. And what is the technical definition of that? So any frame that takes more than 16 milliseconds to load on a device, or 1/60th of a second, is called a slow or janked frame. So you can see these are the janked frames, and all these frames that are in blue are the OK frames. And you can also see the timing here. So it is taking more than 27 milliseconds here, and it should only be 16. So when we do performance overlay, we get this on the device that we are running. So these are two graphs that you can see. One is for the raster thread and one is for the UI thread. So raster thread is basically the scene rendering thread, and the UI thread is where the Dart code execution happens. And here you can see the frame statistics for the last 300 frames. Again, green means it's okay. Red means that it's slowing down. This is again the timeline events chart. And once you click on a timeline, so basically what this timeline events chart does is that it shows all the events that have gone in building the frame. Now that frame both for the UI as well as for the raster thread. So you can see here all the frames are showing up, it's showing the timeline. And it does this for both the main code as well as for the scene rendering. Once you click on any of these events, it will actually take you to the CPU profiler. And this is how CPU profiler looks like. You have summary, bottom up, call tree and the CPU flame chart tabs. And this only happens when you click on an event. The entire CPU profiling information will come up. And we'll also look at CPU profiler in detail. So we'll be doing a case study now. In the first scene, for the first case study, we will be rapidly scrolling down a screen and we will check whether there is any jank. And how will we check for that jank? We'll be using the performance view tool. And in the second scenario, we'll go ahead, we will change the code that we ran in scenario 1 and we will again analyze the performance information. So this is scenario 1, I am running it on the mobile. So you can see we have a list view of gradients and you can see here the raster thread is completely coming up in red, which means that the scene rendering is completely janky, whereas our UI thread is working fine. So now let's look at the performance view tool. So again here you can see it's almost coming in red, which means that all the frames are janky, and in almost every frame you can see jank. So now we will go ahead and look into the code. So this is the code. We are actually calling a list view, and within a list view we have all the gradients as well. So the important thing to note here is that we are setting shrink wrap as true, because of which computation is taking a lot of time, and you can see that as jank. So for improving the code, we will be removing shrink wrap, and instead of list view, we will be using sliver list. So sliver list actually builds dynamically whenever the user scrolls, and with this change you can see we'll be able to let's see the impact of this change on the performance. So we run the performance for scenario 2, and you can see that the janking has now significantly reduced. The red line in the raster thread, the frequency of the red line has gone down a lot. Now let's look at the performance view tool. So you can see now majority of the frames are in blue, and we have been able to reduce janking a lot. So you can see how using performance view tool you can reduce janking. So now we come to CPU profiler, and what this tool helps us in doing is that it helps us in reducing the CPU usage for the app, and we always want our app to use as less CPU as possible, and that is primarily because we want because CPU is a limited resource and a lot of apps are actually vying for it. So the less CPU your apps use, the better it is. It will help in conserving battery, it will help in providing faster UX, and it will not lead to any device heat up issues. And for that we use profiling, which is basically a performance engineering method that is used for analyzing the CPU resources that are consumed by the code. And CPU profiler view will actually provide insights into how much CPU our app is using. So we will be again doing a case study here, which is the Mandelbrot set visualization. So this is basically how a Mandelbrot set looks like. Again, the source code for this entire exercise is available on my GitHub. And just like performance view tool, we will be launching CPU profiler view again on an actual device. So here it's macOS Darwin, because I am using it for a desktop app. Again, we'll be running the app in profile mode, and we'll be opening Dart DevTools in the web browser. So this is the CPU profiler view. So basically, to start CPU profiling, you have to use this record button. To stop, you can simply stop, and to clear, you can simply click on erase CPU usage data. So this clear button will help you to clear it. It's not showing up. Yeah, it's done. Okay, so this clear button will help you erase the usage data. Yeah, it's slowing. It shows here, but it doesn't show there. So now it's showing, but when you go ahead, it starts janking a little. So we have this profile startup mode, and what this does is that before your first Flutter frame is drawn, it will tell you all the details of the CPU samples, and this will help us figure out any issues that we have in startup. Then we have load all CPU samples, which loads data pertaining to any of the isolates, not only your main isolates, but also any other isolates that we run. And then let's go to the third option, the profile granularity. So by default, it is set as medium, which means that every 250 microseconds, one sample will be collected. But you can also set it to low or high depending on your requirements. And you can also export all the data. So we'll be doing a scenario, one scenario where we'll be running this entire Mandelbrot set visualization on the main isolate, and we'll look at how much CPU usage is happening and what is it that we can do. And in the second scenario, we will spin up 4 isolates and we will run the computation there, and we will then see how our CPU is performing. So we'll be running the app in profile mode, and we will simply start recording. So you can see the CPU samples are being recorded. Then we will do everything on the main thread itself, and you can see the render time took around 1408 milliseconds. The next thing that we'll do is that we'll click on zoom 3 times. So you can see the render time is increasing, and the total time it took was 1687 milliseconds. Now we'll simply stop and we'll have all our CPU samples. So you can see all the CPU samples here. So this is basically the bottom up tab. What this does is that it will show you the list of all the CPU operations that have happened in a descending order, where based on the total time. So the operation that took the most amount of time will be at the top. So here we can quickly see that Mandelbrot.iterations is taking almost 74% of our CPU. The second tab is the call tree tab, and this is actually exactly opposite to the bottom up approach, and call tree tab will open up a top down representation of the entire call stack. And here once you click on a method, you can simply expand it and show what all other methods it is calling. So you can see that it's done here. And you can then determine what package or method is responsible for the most CPU usage. And the third tab is the CPU flame chart tab. This again uses a top down stack trace to figure out the CPU usage. And here the CPU usage is presented as a stack. So you can see we have a differential coloring here. So every blue color is basically used, so the width here first defines the runtime. More the width, more the runtime, or more the CPU usage. And all the two differential colorings mechanism is used. One is blue and is orange, and that is used basically to determine whether it's a third party package or the original Dart libraries. And now when we go to bottom up, we can simply identify the method that was taking the most amount of CPU usage, which is the Mandelbrot iterations. So now what we will do is we will go ahead and look into the method itself. So this is the iterations method, and you can see that it is constantly performing iterations for any point in the complex plane till it reaches a particular threshold value. And the way we have called it is that we have a render data function, and that render data function is calling this iterations function for each and every pixel. So you can see this is the render data function, and it's calling the iteration function for each and every pixel. And there are two ways in which you can improve the performance. One is definitely reducing the time complexity, that is figuring out a different algorithm to do Mandelbrot iterations. But that is out of scope right now, and we'll be going with parallel processing. So we will be dividing our computation plane into 4 parts, and we'll spin up 4 isolates to do the iteration here. So when we do that, all those 4 operations will run parallelly. and then we start recording. We'll launch. We have to click on zoom 3 times. And you can see the render time now just took 643 milliseconds. And this is what comes up. Once you do all the recording, this is what comes up. So in the bottom up, we have call tree and CPU flame again. So bottom up, you see that there is no iterations method here showing up. And the reason is that it's running only for the main isolate. So if you look at the bottom, you have main #1. It's only for the main isolate, and we have moved all our operations to the other 4 isolates that we have spun up. So we'll be going to the isolate selector and selecting other isolates. So when we do isolate number 2, you can see so we'll be selecting isolate number 2, and you will have to click on load all CPU samples, and then you can see the iterations method coming up here again. So even for the isolates, it's taking 78%. So you can see it's taking 78%. And now there are 2 scenarios that we ran. One was for the serial execution, where we did everything on the main isolate, and the second was for the parallel execution, where we used 4 other isolates. And we start calculating the total time. So the main isolate took around 357 milliseconds, whereas the other 4 isolates took a total of 137 milliseconds. And because we did it parallelly, we were able to achieve a gain of 2.5 times in performance. So now we will cover the network view, and again the source code is available on my GitHub. And network view basically helps you analyze all the API calls and how much time they are taking, how many times APIs are being called. So you can see it says the method as well, whether it's get, whether it's a WebSocket. You can see the headers, the response. It also shows the status code and the total time that it has taken. Now if you want to investigate any API, so see this get call that is happening. If you want to investigate it, you can simply click on that 3 dots there, this dot, and you can copy the curl. So this is what the curl looks like. So if you want to investigate any API call, simply copy the curl, and you can use any API client of your choice. So say API dash, you can simply import that curl, and that curl will show up. You can import the curl here, and all the things, all the URL params, headers, and the response body and everything will automatically get populated. And then if you want to delve deeper into any API as to why it is taking more time, what is the issue with the response body or headers, you can delve deeper here. So we witnessed basically how these tools can help us, reduce jank in the case of performance view. For CPU profiler, we saw how it helps us understand the CPU usage for our app at a function level. And for network view, we saw how it helps us understand what APIs are being called, how many times they are being called, have we written poor code which is resulting in more API calls, and can we improve on that? So all these things you can do with network view. And that's it from my side. Detailed articles for all these DevTools are available on my Medium channel, and you can follow me on GitHub or any of the social media platforms. So if you have any questions.
Hi, thank you very much for your session. Sorry, yeah. I have one question. I think the DevTool is currently available in VS Code and Android Studio.
Yes.
But recently I've been using IDE Cursor.
Okay.
Yeah, and I was wondering if is there a way to kind of enable DevTool on Cursor?
I haven't tried DevTools on Cursor, and I don't think it's available right now. But yes, it works on VS Code for sure. I'll have to try that out. I haven't checked it out.
Okay, thanks.
Thank you so much for this topic. Just I wonder about network view. I always, when I use this one, is not work at all, always being empty. Is it like because of API call? There is a lot of API call. Is there any limitation in this view?
There is no limitation as such, but if there is an issue with an API, you will not be able to get a lot of detailed view with network view, which is why you will have to go to an API client to see if there is any API issue with the API in terms of request, response, and more details if you want to delve. But as such, what it does is that every icon, every API call that you do, it starts displaying the details, so you can look into that. That's what it helps with.
Do you have like a recommendation on how to prioritize of the three, or even maybe like when you should do this? And like, is it better to kind of get something out there and then kind of optimize later, or?
Yeah. So in terms of optimization, I'll say performance view is definitely the most important, because if the user sees a jank, they think there is an issue with the app. So performance view is always the most important. CPU is not something that the user will feel. If they're using a high-end device, they won't feel it outright. But it will be a problem if there are a lot of apps running on the phone. So CPU profile view is also important, I'll say, but that comes second in priority. And network is again how you write the code. So a classic example is, say in Future Builder, if you are calling an API, every time your widget gets built, it's going to call the API again and again and fetch the result. That is a bad practice, especially if you need the API result only once. So you should basically move it out of Future Builder. So for all these issues, actually network view helps a lot, because when you look at the code, it might be running perfectly and you won't realize that unnecessary API calls are being made. But if you look at network view, you will see that yes, the API is being hit so many times, and this is not something that should happen. So I'll say in terms of priority, it's performance, then CPU profiler, and then network view. And obviously, if you want to get in more details to improve your app, you also have to look at memory view. You have to make sure that there are no unexpected memory leaks. And you will also have to look at app size to make sure that you don't have any unused assets. The packages that you are using are not very, very bulky, and they are not like taking a lot of storage space for the user.
Oh, great, thanks.
Yeah.
Any question? Good. So thank you, Ashita. Please give a hand to Ashita. Yeah, thank you. So let's take a break. So feel free to visit Ask a Speaker Corner for more discussion. The next session is going to start 2:25. Thank you.